Devikar sir, you can start.
Good afternoon to one and all. I am Vikas Devikar. Today, I am giving to introduce the resource person for today's first session. I welcome to Dr. Dnyaneshwar Pawar sir. He is presently working today as an assistant professor, Department of Geography, KSKW College, Nashik. He has NAC coordinator and academic research coordinator in same college. Sir has 14-year teaching experience. Sir has completed his master in geography. Sir has also qualified NET exam. Sir has done his PhD on land evaluation for land resource management, a study of Gera-Shengal land system western Maharashtra. Sir has PhD guide Savitribai Phule Pune University. Sir had completed two minor research projects. He had resource person at 23 state and national and one international level seminar and conference. Moreover, he has published 23 research papers in national and international level journal and presented 46 at national and international level conference and seminar. He had guidance 13 students for dissertation. He had awarded Jagannath Balwant Kumatkar Prize and DM Wag Prize, first in MA in Geography in 2007. Sir also awarded PR Karamkar Prize for dissertation report. Sir published one book. So without any further delay, I request you, sir, share your thought on today's topic significance of pedogeomorphological assessment in the sustainable land resource management and agriculture development, geoinformatic approach. Sir, please deliver your lecture.
Thank you very much. Very good afternoon to one and all. First of all, I am very much thankful to SP College Pune, Principal Dr. Datir Madam, Head Department of Geography, Professor Sunil Gaikwad Sir, the coordinator of this PhD course, Professor Manojkumar Sir, sub-coordinator of this coursework, Professor Davle Sir, for giving me an opportunity to present and share my views with all the research students. Mr. Divekar given my introduction, but I would like to share my one introduction with you. I am past student of SP College Pune. In 2007 PG I have completed from this college, and I have great memories of this college during entire as a student and when I was a CSB in that college. So thank you for inviting me. So with this, I'll start the lecture. So are you able to see my presentation?
Yes, sir. Yes.
Okay. Considering the topic, it is significance of pedogeomorphic assessment in the sustainable land resource management as well as agricultural development. And no doubt, GIS or geoinformatics technology, it is one of the tools which I have been used to study both the world. And I have selected some case studies from different climatic and physiographic zone, that is from Nashik and Pune district of Maharashtra. The presentation will be outlined on this way. So we'll take some time for introduction, that is 2 to 3 minutes. Then why we study or selected this topic, what is the significance of this topic in the research, that will discuss about 5 to 7 minutes. Again, case studies from drought prone area, that is from Chandwad Tehsil of Nashik district. We'll discuss for 20 to 25 minutes, which includes some suitability for grapes cultivation, soil quality assessment, and physiographic impact or geomorphic impact on soil quality and the suitability. The next section will be from some work from my PhD, that is from high rainfall or hilly region from Gera Sinhgarh land system Pune. It required 30 to 45 minutes, which includes the entire land system approach of land facets evaluation in the land degradation assessment, the land evaluation studies as per the FAO's methodology, and integrated land resource management, basin-wise and village-wise planning. And finally, we'll reserve some time for interaction. Now, friends, I am also a student because research is a continuous process. We learn from many persons. So today, what I am going to present, that is work I have done, but I will learn from you people also during the session. Now, what is the pedogeomorphology and what is meant by pedology and geomorphology? Pedology is nothing but the basic science of study of soils, its factors, soil chemistry, soil biogeography, soil physics, etc. And geomorphology deals the study of landform. So integration of this pedogeomorphology provides the framework for the study of relationship between soil as well as landform. So where the interaction and relationship of soils with landform or land facet can be analyzed from the synthetic point of view, that is pedological and geological information with an ecological understanding. So the study of Chatterjee and Day explained all the details related to pedogeomorphology in 2009. Again, the spatial association of soils and landscape, it expressed as a pedogeomorphic surface. The term pedomorphic surface is also used while we use the spatial association of soils and the landform or landscape or topography. Again, the landscape studies represent both the relationship between soil and landform and its pattern of processes in the pedogeomorphic evaluation. This is the essence of applications of pedogeomorphology while we studied the land evaluation from any selected zone, any climate geomorphic or morphogenetic region that helps to identify an ecological homogeneous, a small unit, land unit. Because when we studied at a micro level, so micro level provides you maximum details, it gives you very accurate result, and this is the need of time. Now, why pedogeomorphic research is important? Why it is significant? Why we do study? Because considering any research work, we always consider the research problem. What is the problem? What is the need? And finding this research problem and research gap, we develop our own methodology, or the methodology we adopt from the different scholars. So why this pedogeomorphic research is essential? So as you know, the increasing population affect on different land resources or entire natural resources. Due to exploitation of these natural resources, several problems occur. Increasing population again affect on the land-man ratio, that is decreasing because land cannot change, we cannot increase. So on the available land resources, the pressure of population increases, and due to this, the per capita cultivable land resources of the world decreases. And the situation in India is also alarming. If you look at the picture, in India, the per capita cultivable land resources was 5 hectare in 51 and 52, and which declined up to 0.40 in 2000, and it may be further down up to 0.09 hectare by 2020. So this prediction calls the situation is alarming, because to provide a food security for this growing population of the world, It is necessary to estimate or to study alternative land use options to increase the productivity of land, to increase the production of agriculture crops, and simultaneously with this sustainable rural environment can be considered. So soil productivity, conversion of fallow lands under cultivation, the prioritization, sustainable land and water resource management, sustainable agriculture development and management, all these studies is required at various level, various scale. And in the Indian subcontinent, about 145 million hectare lands require a systematic policy for integrated land resource conservation approach and its execution. In India, the ICAR examined that about 114.01 million hectare land is degraded and wasteland of the country, and 23.60 million hectare land is affected only due to soil erosion, water erosion, that is rainfall and runoff. The National Bureau of Soil Survey and Land Use Planning estimated that about 146.8 million hectare of the country's land is degraded, and therefore it's the policymakers' duty, researchers' duty to find out alternative sources, to evaluate, to assess the available resources, soil resources, land resources, to further increasing productivity, to find out erosion prone zone, to suggest measures for conservation planning, and overall integrated land, water, resource management and agricultural development in the country. So what are the scopes for pedogeomorphic research? There are a number of studies, a number of aspects where the pedogeomorphology can be applied. In soil crop site suitability assessment, it gives you which crop suitable in which region and how much productivity can be increased, which components are required, because improper cropping pattern is decreasing the quality of soil as well as the income and production of the crop is also less. So for this, if we suggest the suitable cropping site for particular zone, particular soil area, it will improve the quality of soil as well as improve the production of soil. Then soil productivity, so which gives you the current status of the production of soil, considering various geomorphic and soil parameters, climate parameters. Agricultural land use planning. Up to parcel level, we can plan an agricultural activity. Nowadays, very high resolution satellite data is available. Using this, current utilization trend can be found, and on the basis of this, agricultural land use planning can be suggested. For that, the methodology designed by various agencies, that is land capability and suitability, land evaluation can be applied. So land resources can be evaluated for this. Soil property study is one of the major significant part of pedogeomorphologic research, whereas soil survey at various scale with appropriate method is essential for any type of study. Soil drainage, soil hydraulic conductivity, soil drainage is one of the significant component in cropping and agriculture. Integrated sustainable watershed management, so management in drought prone areas, wasteland restoration and management or fallow land restoration, monitoring of surface agriculture and land and water resources, and overall land degradation assessment in terms of soil loss estimation, runoff estimation, water logging, salinization, siltation, desertification. So all degradation can be assigned, and for this pedogeomorphic aspect is important. And again, including this, there are a number of aspects where we consider this pedogeomorphology as a research. Now come to the point of technology, use of technology. In the title, I have mentioned using geospatial technology. So what is geospatial technology? That you know, it is part of GIS, remote sensing and GPS. Use of this technology is nothing but it is a geospatial technology. Friends, the father of Indian remote sensing, Dr. Vikram Sarabhai, expected from the policymakers, researchers that we should apply or use this advanced technology to solve the real problems of man and society. So remote sensing is one of the technology, geospatial is one of the technology that we can apply to solve a problems of man and society. And therefore, it is one of the powerful tools that we always use. Now, many students or many researchers use this as an application or use. But in my title, I have used using the geospatial technology, not an application of geospatial. Because application is very much scientific, mostly we need to use the word using. Application is more complicated. We cannot develop more applications because we only using the satellite data or remote sensing technology. Yes, if you have developed your separate plugin in GIS software or a separate program, that time you can use the application word. So considering this aspect, there are applications of geoinformatics and geospatial technology in the studies of physical geography as well as human geography, and it is significant in pedogeomorphological research also. Why? Because geographers' role is the spatial analysis. Geographers are expert in the spatial analysis, and therefore it is powerful tool to solve the real problems of the society. Now, previously, several scholars have been applied this geospatial technology, that is GIS and remote sensing, as an appropriate tool for evaluating and managing of land resources. I have quoted some names of them, those who have applied this GIS remote sensing technology in pedogeomorphological research. Now, why I have selected case studies from Nasik and Pune district? Yes, of course, it is part of my some project or some PhD work. But for this, why I have selected this one for pedogeomorphology, not from another region? Because the statistics or the facts, research gap shows that amongst the all types of soil erosion, that is induced land degradation, the water erosion is topmost and very severe. And the average amount of water stimulates soil loss in Maharashtra, that is about 94% is only from water erosion. That is 773.5 million tons. And National Bureau and Soil Survey and Land Use Planning mentioned in the annual reports in 2005 that 11.2 million hectare lands of Maharashtra affected by the water erosion. And amongst these, the Pune district ranked third after the Nasik. It means that Nasik ranks second and Ahmednagar ranked first. And therefore, the studies, pedogeomorphological studies selected from both the seal because both districts affected due to very severe soil loss and it degraded the productivity of soil. Now, the first section, that is the study from drought prone zone. Basically, this is my native Tehsil place, Chandwad Tehsil, from Maharashtra or from Nasik district of Maharashtra. I have examined or assessed a soil properties physiography in that particular drought prone zone for sustainable land use planning. Because the situation in this Tehsil is very worst. During the rainy season, only some water people get and some water used for agriculture. But maximum time water scarcity problem is there, erosion problem there, severe runoff is there due to several social problems were raised. So why this study is important that we have already discussed, and in this study, attempt has been made to evaluate soil resources, pedogeomorphic resources from this drought prone zone. This is the physiography map of Nasik district. The district can be classified into three major watershed zones. That is Upper Girna, Upper Godavari zone, from Satmala Hills to the southern side and from western to eastern side. This is the Girna Reservoir catchment, and it joined to the Tapi. Here, the western zone shows the west flowing rivers Banganga, Par and Nar. So, the climate is like Konkan here. Here, this is the Satmala hill ranges. Here, Galna hills ranges are there. Salyer is the topmost 1567 meter elevation peak point in the district. And now you can see this is the Chandwad Tehsil. This color, that is 700 to 800 meter maximum, and above than 800 to 900 meter. Notice in this Tehsil, and considering the physiography, drainage and climate, the situation, the Tehsil is always face a problem of agricultural development and overall socio-economic development. Now this is the satellite image IRS P6 LIS 4 5-meter resolution image, and you can see this green color or whitish color indicate the fallow land and wasteland, and in entire Tehsil you can see the proportion of fallow land is maximum. I have already calculated the land use land cover classes, in that you can see. But in eastern part, from all the drought prone zone, because Baglan, Malegaon, Nandgaon, Devla, Chandwad, Evla, Sinnar, all these are the drought prone zone of Nasik districts. Now, the land use land cover of Nasik district shows about 62.70% land comprises under cropland. So it means that crop is agriculture is dominant activity in the district. So agricultural fallow land is 5.15%, that is 799 square kilometer. So our role is here to find out the potential of this fallow land and to suggest measures, remedial measures for converting this fallow land into agricultural land if the proper irrigation facilities were provided. Barren land, fallow land, and another part is in the western part, the zone is eco-sensitive in tribal areas, and therefore no development can be occur in this area as an industry and other things, and therefore only one option is agriculture in the district. Now this is the drought prone tehsils map of Maharashtra. Yellow color indicate all the major drought prone tehsil of Maharashtra, where the severe runoff and soil loss in Nasik district can be seen from this eastern part of drought prone tehsils, scarcity of water, poor economy, traditional crops and social issues. Friends, several social issues occur in this drought prone area. Because of these natural calamities or natural components, the agricultural production is less, therefore economy is less, and social issues like migration, even social issues related to marriage also occur in this drought prone area, because people not ready or ready to marry with boy or girl in that particular zone, as the tehsil facing the problem of water and poor economy. And therefore, if we calculate, if we see the proportion of major gross crop area, that is all the cropping pattern in the district, comparatively in the drought prone zone and in another zone, you can see till the date there are traditional crops growing by the farmers. You can see bajra, proportion of bajra is maximum, jwar is maximum. So some tehsils nowadays using some crops like tomato. Here you can see in Evla and Chandwad tehsil, they have started growing the crops like tomato and some vegetables. But till remaining tehsils, drought prone tehsil, not using all this. and therefore this is the need of time to find out the quality of that resource. So location map of the study area, it is Chandwad Tehsil from Maharashtra, Nasik district, and comprises about 958 square kilometer area, including 112 administrative villages. This is the National Highway 3, Mumbai, Agra, and this is the Chandwad Tehsil, Tehsil headquarters. Now look at this picture. Why the situation in Tehsil? What is the situation in Tehsil? Everywhere barren land, fallow land, eroded surface, the crop burn due to the less water, and maximum period is this borrowing of land. So this picture calls the need of study. Another fact, the population depend upon agriculture. The main population depend cultivators. About 59% of total population of Tehsils are cultivators, and agricultural laborers are 29%. It means that in every village, cultivators and agricultural laborers are dominant, and they all are depend upon agriculture. If the sustainable agriculture plan develop and the agriculture production will increase, proper land utilization of agriculture were maintained, the economy will be developed, and finally the cultivators and agricultural labor directly and indirectly get the help from this research. So this is our use of research for the local community also. The methodology adopted for this study is geomorphology section and pedology section, where in geomorphology, topo sheet is one of the best source that is used for preparation of base map, satellite data, studium, and the list for satellite image were used for find out present land utilization trend. MBBS and LUP map of soil types and land erosion were used for assessment of productivity. Soil survey were conducted for collection of soil samples and soil hydrological measurements. After this, data were processed in a GIS format. For that, vectorization and rasterization both used. Map, toposheet, georeference, mosaicing were done, and all the point line and area feature were digitized for further analysis and use of this in a final production of map. Then digital elevation model used for relief properties analysis, geomorphic parameters estimation using neighborhood analysis, GIS software, elevation, slope, absolute relief, relative relief, dissection index were calculated, and all used to estimate the productivity of soils. Then soil sample were analyzed for physical and chemical properties, and soil drainage parameters like hydraulic conductivity and infiltration rate measured, and all these converted into raster format for the same grade. For this, ranking of parameters and weighing of weightage factor, weighting of factor assigned for each and every raster map. Resampling were done in a GIS software using raster calculator, and finally the productivity of soil were calculated and the spatial variation map is prepared. The story index method of land productivity is used to develop and modified using geoinformatics based land productivity method of the present investigation, which include several factors: soil texture, that is sand, silt, clay, soil types, the permeability of soil, that is hydraulic conductivity, again infiltration rate capacity, soil chemical properties, soil drainage, climate condition, etc. factors considered to find out the productivity of this drought-prone Tehsil. And the formula were designed by Story, assigned to all the input parameter map in the GIS environment, and finally the calculation done, multiplication were done, and final product were estimated. And on the basis of this, story index grading were calculated, which calculated from excellent, good, fairly, poor, very poor to non-agricultural land on the basis of index value, and its characteristics were assigned. This is the IRS P6 list 4 satellite image of Tehsil from 2014, and the analysis where shows that out of total land surface area, that is 958 square kilometer of the Tehsil, about 51% land is agricultural land and 30% land is agricultural fallow. Means in district 5% land is agricultural fallow, but in this Tehsil 13% agricultural land, fallow land is estimated. Whereas barren land, that is land with scrub, without scrub, is also noticed, calculated, and it is about 23%. Means this 23% and 30% land, we can find out its potential, its quality, and we can reclaim this land for agricultural purpose. This is geomorphic map of this Tehsil. Maximum land comprises under the undulating topography, that is 76.87%. Hill summit and spurs only 6.77%, that is to the north side of Tehsil, and remaining area is plain and valleys, that is 16.36% of the total area. This is the extent of elevation, which gives you about 71% of total Tehsil area, that is less than 700 meter elevation from this entire, and remaining is 30% only. Whereas this red color indicate the Satmala hill range, which comprises about 2% of area of total studied area. Maximum height is 1371 meter and minimum height is 548 meter to the east part of this. This is the drainage. Some from B1, B2, B3 and B4, all this water or drainage joined to the Girna river, and from A1 to A8 joined to the Godavari river catchment. And for the further planning, water this drainage were divided into separate sub-basins. 27% area comprises under this east flowing, and 72% comprises under the west flowing. Actually, it is vice versa. This is east flowing and it will be west flowing when we consider entire Tapi basin. Now, the absolute relief shows 68.89% area comprises under 600 to 700 meter. Now, friends, the values were assigned considering the potential of its erosion for the estimation of productivity of soil from all these absolute relief, relative relief, dissection index maps. This dissected index map gives you idea about the dissected topography, which contribute the soil loss as well as reduce the soil quality in that area. 2 to 3% land 2 to 3% dissected topography comprises 26% area, 1 to 2% comprises 146% area, and less than 1% dissected topography comprises about 78% area of the total district Tehsil. Here in this map, slope, it is one of the input parameter of productivity of soil. 75.40% land comprises under less than 5% slope. So plain topography is there, and 5 to 10%, 100 that is 160 square kilometer area of Tehsil comprises under 5 to 10% slope. Whereas this red patches shows the slope more than 30%, that is steep slope rocky lands from the Satmala hill range. Again, for the requirement of productivity of soil, physical and chemical properties essential, its texture is essential, and to estimate this texture, soil properties, the soil survey were undertaken. Considering the land use land cover and the various slope in it, systematic soil sampling were done, soil drainage were measured, and this is the map which shows the soil sample collection and field measurement site. After this, all these samples were analyzed in the laboratory and the values assigned to X and Y coordinate for spatial analysis and Z coordinate as a component of this parameter. And final, all the required input parameters spatial variation maps prepared. This is the infiltration rate variation map, which gives you eastern part is poorly infiltrate, whereas western part is good for soil productivity. The eastern part of hydraulic conductivity is also poor, whereas western part shows western and southern part is good for agriculture. The percentage moisture shows where the irrigation source is available in that zone. The moisture percentage of moisture is good, but in the plateau summit surface near to the bare hill slope, the percentage moisture available in soil is very poor, and in eastern part it is also poor. The pH variation shows the soil is good for soil is good for agriculture because there is unavailability of irrigation sources, over irrigation, and less less water. The pH is good in range. The soil type shows soils of summit and spurs is anti-soils, that is well drained from loamy, moderately sloping, and soils of undulating land, that is very shallow, excessively drained, and loamy soils. Soils of undulating land, that is slightly deep and moderately deep. Soils in plain and valleys, this is plain and valley, yellow color and green color. Well drained and clay soils. Then in septic soil, that is vertic upper soil soils, slightly deep, moderately well drained and fine. Vertisols, moderately drained, free soils and very gentle sloping, plain and valleys. All these soil type map is regenerated or reproduced from National Bureau of Soil Survey and its planning map. The soil erosion shows in entire Chandwad Tehsil, the soil erosion toward the east part and toward the north part is very high. That is from severe to extremely severe. In the eastern part, that is in Kannadagaon and Kundalgaon village and some part of Wagh, Varadi, Nimona and Dugaon village, where the soil erosion greater than 80 ton hectare per year, extremely severe. And I am also coming from this village, Varadi, and I have noticed all this soil erosion in that particular area. 40 to 80% soil, that is very severe, noticed toward the north part of that tehsils, whereas remaining part is classified into very slight to moderately soil erosion. And therefore, from this moderately severe to very severe, this zone is need to consider a proper measures to reduce the soil erosion through a proper agricultural planning and sustainable land resource management plan. There is good relationship between geomorphic components and soil characteristics, that is land use land cover, soil types. The green color shows very strong relationship and the dark red color shows very negative relationship, whereas yellow color shows moderately significant relationship with all these components. Now, on the basis of all these input parameter, final spatial land productivity variation map is prepared, and which gives you result in the area excellent land productivity is totally absent, whereas good productivity covered almost 24% of the total area, and from fairly to very poor, that is 36% in fairly good, poor, that yellow color indicate poor. Now here you can see in the eastern part, poor soil where the soil erosion is high, and very poor, that is 9.51%. Whereas this red color indicates non-agricultural land, as it is escarpment, hill slopes land, and this blue color indicate water bodies. Now there is scope to develop this fairly good and poor or very poor land, convert into good land productivity using appropriate measures of sustainable soil resource management. Again, attempt has been made to find out the erosion prone area. The simple analysis of two different times grid were generated, and the volume of each basin were calculated, cut surface were calculated, percentage of area were given, and on the basis of this, the basin wise priority has been suggested for this entire area. In the eastern part, the B4 and B3 watershed given the first priority for B1 and second priority given for this A3 watershed. On the basis of this, area were also calculated for each and every watershed. Overlaying watershed, overlaying boundaries on watershed, that is village boundary, village level soil loss were also calculated, and about 86 villages comprises in the Godavari river catchment and 26 in the remaining part. And accordingly, in every watershed, the priority level of every village were assigned from where the conservation program should be undertaken. So I think you have clearly understood the eastern part is affected, severely affected, and there is no source of irrigation. And for this, I have done some small study to find out the suitability for dam, because near the Chandwad there is hilly region, and from this hilly region the rainfall is good as compared to another part of this zone, and there is chance to develop a dam, and using this water the eastern part can be irrigated through a natural stream also. So it covers 1 to 10% category of slope. This is the geological structure that you again consider need to develop a dam. The barren land is 52%, 38% is agricultural land, and the dam site suitability we are calculating using this geospatial technology. Here this is the dam site suitability, and using this gravity or natural streams, expect some things. The red lines indicate where we need to develop a canals or flow this water from one stream to another stream. Like this, entire eastern part can be converted into irrigation or irrigated portion, and that will be helpful to development of irrigation in that particular zone. Although it is drought prone zone, but sometime rainfall get in the near Chandwad from that rocky outcrops, and that can be stored and used for this eastern part whenever the water is available. Another thing, that up to ground level, up to parcel level or gut number level, the cropping suitability pattern we need to suggest. And for this, one village, that is Raud, selected for the grape site suitability. Again, you can see fallow land is 60%, and this is the methodology of grape site suitability on the basis of soil site suitability criteria of National Bureau of Land Use Planning and Soil Survey. All these are the land quality indicators: climate, oxygen, nutrition, rooting, soil toxicity, irrigation, erosion. And this, using this appropriate methodology, base map preparation, relief, soils, field work, all these parameters were standard grid were prepared, raster grid, and the ranking were again assigned, very well performed. and spatial soil suitability for grapes is calculated. Like this, we can suggest different crops suitability, onion and another thing according to climate situation in that particular area for the proper utilization of land. Again, sampling is required. All input parameters are required. That is soil drainage, soil pH, NPK, soil carbon, then to slope, soil erosion, and finally, all these input parameter we can assign the values as per the suggested methodology suggested by National Bureau of Land Use Planning and Soil Survey for particular crop. Resampling can be done, grading and weighing can be assigned, and finally applying the query analysis, the suitability site for grapes were find out. Here you can see in that particular village, the red color shows the area is not suitable for grapes, entire area. It may be rocky, it may be barren or fallow, or the productivity is not good. But highly suitable to marginal suitable land is delineated for grapes cultivation. That is marginal suitable is 23%, highly suitable is 23%, and 27% is moderately suitable. So this marginal and moderately suitable land again can be converted into highly suitable for grapes using the appropriate measures. So this is one type of suitability for grapes cultivation. And in the ground we were check the accuracy. Some people were develop their grapes plantation in a marginal suitable land, and their productivity is less as compared to highly suitable land. So we have suggested them to use a proper method, to use some microbes and all the details to check soil every year. And the policy document we have also provided to Gram Panchayat level, because up to parcel level, up to gut number level were the suitability were calculated. Here another one thing, from this village you can see up to gut number level the suitability we can suggest. So using this we can develop a simple methodology to find out suitability and suggest for increasing the productivity of soil and increasing the production of that particular crop. So it will be help the the various cropping pattern will be developed, and the loss of monoculture due to monoculture will be less. And this is the again conclusion. So all this concept is from the drought prone zone, that is from Sandwad Tehsil. From Tehsil level to up to village level, agricultural land use plan we can suggest. For that proper methodology need to adopt for soil survey according to various land use pattern. Current land utilization trend is need to find out, and how much our research is useful for policy making for the common people, that is also significant. Because what we do, that if we suggest for the policy maker to develop their policy for sustainable development, that will be more helpful. So therefore our suggestion should be whatever result will be there, so accuracy assessment is required. Because yes, I have done some work, calculated some values shown in the color map, it is good, but what about the accuracy? So the accuracy assessment is required, and after the accuracy assessment we can suggest the plan whether it is applicable or not applicable. In this again the research cannot stop. Cost benefit analysis it should be need to undertake, and finally we can give this as a policy document to implement the ground level. So this is one section. Now we'll move for another section, that is the studies from high elevation or high irrigation zone, high elevation and high rainfall zone. That is some work from my PhD, that is land evaluation. Actually it is not title of PhD work, but I have changed some components only show the land evaluation index from this study. So land evaluation index for sustainable land management using land resource management using again the tool GIS. It is a case study of Gera Segar land system, Western Maharashtra. Many of you might visited the Sinhagad Fort. From the Sinhagad Fort towards the west side, you can see the Sinhagad Valley, Khamgaon Valley, and this Khadakwasla Lake catchment, and towards the east side, this is the upper Shivganga Valley, and this is the Khamga Valley. This is the Sinhagad Fort. Again, while doing the study, introduction is essential to find problems. On the basis of this problem, we can suggest what is the need of this study, and which method you are going to apply for this study. That is land evaluation. What is the land evaluation? Which are the methods available? What is the literature survey is there? And apart from all this study, how your work is different. For this, you need to find out a gap of research for the particular area also, because the same land evaluation method cannot apply for every area. Considering the climate condition is very different, rainfall pattern will be different, soil characteristics will be different. So we also need to modify the method as per our condition using a proper quotations, proper literature from our country or our region also. And then on the basis of this, our results value we can recheck from the work done by a proper government institute, some researchers, and on the basis of this we can proceed. So land system, what is the land system? It is the approach that is very significant for the analyzing a smallest homogeneous unit or smallest part of land unit, that is known as land facet. For example, look at this picture map. Here, this is the homogeneous unit, the hill summit surface. So it has the separate characteristics, whereas the plain surface has separate characteristics. And when we do the study up to land facet level, micro level, it will give you more accurate result for the proper conservation planning. And therefore, the land facet approach has been considered in a land system. It is a combination of land facets together, forming a convenient mapping unit on a micro level scale. And the studies, again, I have already explained the significance of this study. And in Western Maharashtra, most of the land facets have been degraded to their maximum due to a lack of best management practices. Again, erosion is high. Pune district is ranked second in Maharashtra due to water erosion. And therefore, if the proper steps in view of this land resource management are undertaken, the land units can be reclaimed for proper utilization. And the major objective of this study is to prepare land inventory of each and every geomorphic unit to compute land evaluation index of land resource management using the soil survey methodology. These are some specific objective of the study: to perform land classification into different geomorphic unit, that is into land facet for entire Gera-Segar land system, and thereby to assess the potential of terrain and soil with respect to land capability, suitability, classification, and soil productivity assessment. To develop and estimate land evaluation index, to identify high priority risk zones, erosion risk zones for land degradation assessment, and to suggest compensatory conservation measures in the study area to minimize the surface runoff and soil loss. To study and prepare village level land resource inventory, to prepare land facet wise land resource management plan within a framework of land system approach. This is the study area. It lies in Velle Bhor and Haveli Tehsils, and about 28 villages comprises. This is the administrative location and boundary overlay, and this is Gera Sinhagad land system. At the center, Sinhagad Fort is there, and to the this part, this is the Khadakwasla Reservoir catchment. This is the Upper Shivganga Valley. This is Khamga Valley. This is Sinhagad Valley. About 131 square kilometer area is comprises by the entire Gera Sinhagad GSLS. About 28 villages from Haveli Tehsil 21, Velle and Bor 4 and 3 respectively. And the total population is 32,390 90 as per 2011. This is the database and sources: topo sheets, geology, satellite image, soil data, where field work were undertaken, rainfall, population, infiltration is required, and the land facet geomorphic map. Again, same methodology with some changes. The base map and terrain analysis. Base map prepared using SOI topo sheet, while georeferencing, mosaicing, and digitization. And the basis of this map, the boundary were delineated, land facet calculated, tehsil boundary overlaid, and land unit land facet were calculated. Using satellite data, ASTER-DM, the relief properties were calculated. Using remote sensing data, the land use land cover were estimated. Soil survey were undertaken for collection of soil samples, hydrological measurements, soil profile observation, soil depth measurement. Land degradation assessment, that is evaluation, were done. So soil survey, analysis, mapping, evaluation, and all this, it is all in a pedogeomorphology. Land degradation, runoff, and soil loss were calculated, and in the land evaluation, land capability, suitability, productivity, land evaluation index were calculated. Using runoff and soil loss, land degradation index were developed. All these data processed, collected, analyzed, and the different raster layers were prepared. Using GIS technology, neighborhood analysis, relief analysis, then raster analysis, the result were calculated with standard grid and elevation, slope, absolute relief, dissection, runoff, land erosion, capability, suitability, productivity. All these component ranking of parameters and assign of weightage given to according to its importance. Reclassification of grid were done, and final land evaluation index map of the study area developed, and on the basis of this, the suggestions were given. This is the land facets map. Land facet map of Gera-Sinhagad land system. This is the sub-basin. Now, in the 3D view, you can also get the picture of entire study area. It is hilly region, and in this region, the area under different land facet were delineated. In the GSLS, plateau summit surface comprises about 36%. That is this plateau summit surface, this land comprises about 36%. Plateau fringe near the plateau summit surface covers about 28% land of the GSLS, whereas pediment surface, this land, this is the pediment surface, this comprises about 28% land, and plain surface covered about 14% of total land surface of the study area. Whereas Sinhagad can be considered as a mesa or bit, it again occupied some, that is escarpment, 0.09% of the total area. So in this present investigation, attempt has been made to apply this land system approach. The land facet is a vital concept for land resource management. This is the rainfall variation map of the study area. It ranges from 800 to 900 to 750 millimeter. From east to west, it shows increasing trends, and it is one of the input parameter for estimation of surface runoff as well as soil loss. This is drainage stream order map, and according to this, sub-basins were delineated. These three basins, Sinhagad Valley, Upper Shivganga, and Khamga, are the fifth order drainage basin. Here you can see fifth order drainage basin comprises 86% of the total area. Fourth order comprises 5%. This is the fourth order GSLS 12. One basin is comprises under this. Third order comprises 5.55% area, whereas in second order 3 total sub basins comprises, and in first order all first order 14 basins included, that is 1.41%, where the linear parameters calculated for each streams or basis. All these are the terrain properties of this study area. Elevation shows it ranges from 500 to 1312 millimeter. In hill summit surface, hill free surface, it is very high, steep slopes are there. Accordingly, it affects on the relief, absolute relative relief, dissection index, and you can see the dissected topography, more than 80% dissected topography noticed in hill fringe surface, hill summit surface, whereas less than 40% dissected topography delineated in a plain surface land facet. The slope is one of the input parameter of estimation of soil loss, that is estimation of slope length. Here the percentage slope map is shown, which comprises max 27% area under moderate slope, that is 8 to 50%, and about 32% area is under moderately steep, that is 15 to 30%. This one, and this is the more erosion prone zone of that particular area. Now again, the correlation matrix of absolute relief, relative relief, dissection index, and slope shows the relationship, good strong relationship and moderate relationship in some aspect. The land use land cover again essential to find out present land utilization trend, find out current fallow land, waste land for suggestion and management of these resources, evaluation of these resources. The land use land cover is one of the input parameter of universal soil loss equation, as well as it is one of the parameter of estimation of surface runoff to find out land degradation potential of that particular area. You can see using list 3 FCC 2003, the digital image processing has been done, and in the area about 41% land is wasteland, which include barren land, barren rocky land with scrub, gullied and ravinous land, whereas 43% land is agricultural land. Now, for land degradation assessment and to find the quality of soil resources and to suggest land resource management plan, the proper soil survey is required, and maximum soil sample if you undertake in the field, that gives you very good result at micro level, because while considering maximum area and collecting a less sample, it may be gives unappropriate result, or the result quality will be less. Therefore, we need to collect soil sample according to a systematic level, according to different slope unit, different land use land cover pattern, and accordingly the field survey were undertaken, soil sample were collected, about 361 soil sample according to slopes and land use pattern. Field measurement of infiltration capacity and hydraulic conductivity were measured, and the benchmark were located, ground truthing analysis were performed, and you can see in different slope unit soil samples were collected. Less than 10% slope, the 93 soil sample collected, 10 to 20%, 134%, 20 to 30% slope, 85 soil sample collected, and accordingly all these soil samples were collected and analyzed in the laboratory. Now here you can see the slope is also classified according to land facets. Land facet wise slope map here prepared for land fringe surface, summit surface, pediment surface, and slope surface. Within this, the very steep to gentle slope classified, and area under each were classified, and accordingly The pedogeomorphological approach will provide a conceptual as well as analytical framework for studying interaction among all the components of landscape. The soil landscape model is important for land evaluation, for land use planning, and it provides data and information for terrain as well as the properties which required for land evaluation. Here you can see, according to land facet and different slope unit, the soil properties, average soil properties were calculated, and finally entire soil properties quality index were estimated to find out the land evaluation index of the study area. Here you can again get the details in every land facet, the different physical and chemical properties as well as drainage properties of soil calculated. For plateau summit surface, here you can see coarse sand, fine sand, silt, clay, bulk density, specific gravity, porosity, moisture. Chemical properties include pH, total soluble salt, organic carbon, organic matter, carbon, phosphorus, potassium, and all these components. And finally, for pediment, plateau fringe surface, for pediment surface, plain surface, all these surface wise, land facet wise, soil properties quality were calculated, and the slope and height elevation relationships were also performed to find out the relationship between these properties and the slope soil properties. Here you can see how slope affect different soil properties. The dark green color shows strong relationship in moisture, total soluble salt, bulk density, percent sand, silt, coarse, like this. So maximum, the square shows green color, it means there is good correlation between soil properties and the slope. This is soil depth, one of the input parameter for land capability and suitability. 27% soil comprises under shallow, 36.8, moderately shallow 60%, that is 60 square kilometer, that is 46% of the total area. These all the textural properties were required to find out soil type map as well as to estimate the permeability of soil in the soil loss equation. So soil type map is one of the input parameter of universal soil loss equation. Again, it is required to estimate hydrological soil group in runoff also. This is the organic carbon map which required to prepare soil sample analysis data. This is the infiltration rate variation map. Moderately slow to moderate runoff categories comprises maximum area of total Gera-Srinagar land system, that is 80% of the total area, and it is one of the input parameter of universal soil loss equation. Now, attempt has been made to find out runoff, because due to runoff soil erosion is increases, and runoff were calculated using NRCS SCS curve number method. Curve number were estimated applying the different values hydrological soil group. And input parameter required for runoff are rainfall distribution, land use land cover values, soil types, infiltration rate variation, hydrological soil groups, and curve number. And finally, for Indian condition, this equation were applied. All the input parameter were calculated: rainfall, soil types, infiltration, land use, hydrological soil groups, and curve number. And for hydrological soil group, soil types, organic carbon, texture are required. For curve number, present land use pattern, organic carbon, infiltration rate, soil texture are required, and the curve number values assigned according to Dhruva and Narayan methods for Indian condition. And finally, all these input parameter used to find out the surface runoff map of the study area. And here you can see there is very high impact of rainfall and the slope on the surface runoff. The surface runoff ranges from 625 millimeter to more than 1600 millimeter towards the west band. Maximum surface runoff notice in the very severe runoff category notice in the this Khamgaon watershed. Sub-basin wise runoff categories were calculated, average runoff and runoff volume were estimated for further prioritization and conservation planning. Now another thing is that estimation of soil loss that we have already explained. In the western zone of Maharashtra, the red patches shows the very severe or alarming situation of soil loss, and therefore this area is need to undertake conservation plan, need to undertake a research for estimation of soil loss. This is the universal soil loss equation methodology that I have adopted. Rainfall, soil data, infiltration, topo sheet, and remote sensing used as a input database for preparation of input parameters. Rainfall variation map prepared using Roses method. Soil texture and organic matter map used for soil erodibility nomograph, infiltration, TM. Like this, all the RKLS CP component input parameter calculated, sub-basin wise soil loss, land facet wise soil loss estimated. I think you know USLE. This is the R factor. This is K factor. K factor calculated using soil erodibility nomograph. This is the nomograph using the percent silt, percent clay, and organic matter and structure permeability factors. LS slope length calculated using DM and topo sheet. C factor values were assigned according to Dhruva and Narayana on the basis of land use, land cover. And for P, again, the values assigned for conservation practice using this Dhruva Narayana applied for Indian hilly condition. And finally, on the basis of this, soil loss were calculated for degradation land. And here you can see the red patches shows very severe soil loss, and about 63.48% area under this study area is comprises less than 2%, less than 5% 5 kilogram meter square per year soil loss, and the entire area average soil loss is 4.5 kilogram meter square per year. Land facet wise soil loss estimated, and here you can see the in plateau summit and in plateau fringe summit surfaces the severe to very severe soil loss is maximum, whereas in plain surface and pediment surfaces the very high to low severe soil loss calculated. These are the snaps which gives you the condition of soil loss in the study area. This is the land passage wise area under different soil loss. And on the basis of this runoff and soil loss, land degradation index map prepared, ranking were assigned for soil erosion, runoff, and finally compound values were assigned, and land degradation index map according to land facet were calculated. Low degradation covers 7.5% land, whereas high degradation covers 24% land. Very high comprises 17.61% on the basis of USLE and runoff. And finally, sub-basin wise, this priority were calculated, land degradation index calculated, and prioritization suggested. The land evaluation again include land capability, land suitability, and land productivity estimated. According to FAO's methodology, mapping and analysis done, sub-basin wise and land facet wise soil land capability suitability calculated. This is the land capability rating map, degree, texture, soil depth. This is general land capability, and for specific crop, we need to follow another. All input parameters, soil properties, and finally, the same techniques were used. The land capability map prepared in the area. All the 8 land capability class noticed, and area under this class according to land facet were calculated. Maximum area comprises under the category, that is third category, 43% square kilometer area comprises under the third land capability class. This is the land suitability methodology, which is used using GIS, and the land suitability map were prepared. Maximum area comprises under marginal suitable land, that is currently not suitable for agriculture, 27.54%, and highly suitable, that is 27% land. The land facet wide land suitability were calculated. These are the classes in the ground: highly suitable, extremely suitable. The best on story index method that I have explained in story index, excellent to very poor ratings assigned, and the 27% land comprises under the fairly good soil. And this is the land where we can restore, regenerate for the cropping purpose. And finally, all these parameter, all these current properties, land capability, land suitability, land degradation index, pedogeomorphic components, the attempt has been made to develop land evaluation index, which is modified method for the study area, and the ranking parameter assigned weightage according to importance of parameter. Here you can see the variables given weightage for this variable according to class and according to its importance were assigned, and one standard grid maintained for the analysis. And finally, the formula assigned using raster calculator, and final land evaluation index map prepared. The land evaluation index values from high to low will shows extremely high suitable land evaluation unit to moderately low suitable unit. This is the land facet wise land evaluation index final output, and from low to extremely suitable land evaluation areas were delineated, and land facet wise it is calculated. So on the basis of this, we can conclude that the major geo-environmental problem in the study area are soil loss and severe runoff. Runoff estimated, that is, I'm not going to explain each and everything detail, but how these techniques we can apply it for agriculture. For this, land resource management plan is suggested sub-basin wise, wasteland restoration, ecotourism, land facet wise catchment area treatment plan, or CCT contour burn trenching, farm burn trenching, drainage line treatment, village level plan is suggested. For this, again, to implement this plan, the watershed level management concept should be applied that define the objective, understand watershed, selection of watershed, study of watershed, collection of database, mapping analysis, integrated land resource management plan, prioritization, implementation, and monitoring. We are here for prioritization. The next is implementation. This is the prioritization based on soil loss runoff studies. This is the suggested measures according to sub-basins area is given. So contour burn trenching, contour trenching were suggested according to NABARD's guideline. Suitability were delineated according to different land facet. Here you can see this is the contour trenching suitability in ground area were estimated at village level. This is the site suitability for contour burn structure, and this is the criteria, the area estimated. Farm burn structure, this is the criteria, area calculated, and finally all these measures were calculated for each and every sub village. This is earth plug, gully plug, border gully plug, and cement burn structure suggested according to surface runoff and soil loss. This is the earth burn gully plug. This is the example, and for every village, current land use pattern is considered. This suggested measures is calculated, and the details were statistics were calculated for land resource management plan at village level, and the final land resource management plan is prepared on the basis of land evaluation index of the study area. So on the basis of these presentations and the studies from drought prone zone, agriculture, as well as this hilly terrain, we can conclude this today's presentation of pedogeomorphic significance in land resource management as well as sustainable agricultural development. Where is our geographer's role? Where is our strength? Our strength is spatial analysis to systematic use of these tools and techniques, systematic surveys, and selection of area according to its need. That is our role. And finally, we can conclude that this GIS remote sensing technology is wonderful and extraordinary tool which provide the new innovation in pedogeomorphic research. Expect the user's behavior or user's approach is more significant in this study, because whatever you provide to that techniques, it will shows the result. And for this, proper ground level analysis, experimental exercises are essential. Then its verification of result is again essential. Pedogeomorphic research is part of applied geomorphology and environmental planning. We can contribute from this as a geomorphologists, geographers. This research may be useful to solve some or reduce some real-time problems related to land, water, agriculture resources at various geomorphic scale. It is also significant to contribute solve the issues related to food security, not a food security, but increase the production, sustainable resource management, agricultural development, increase the productivity, watershed management, and through this, some socio-economics problem will also resolve in this area when this techniques, this research will be applied in that particular area. With this, I am very much thankful to Professor Dnyaneshwar sir, my guide mentor, Dr. Sunil Gaikwad sir, for giving me the opportunity to present my work or express my views related to research work in front of the research scholar. I am again speak that I am student of this college, and now again I am student. Why? Because the research cannot stop. There is always chance for development and corrections. So I request you all kindly ask some questions, kindly give your suggestion for further improvement because it is essential for further research. Thank you very much. Yes, Devnesh sir.
Thank you, sir. Thank you, sir. The session is open for question and answer. Please ask any doubts or any questions if you have. I think, Doipude, sir, you raise your hand. Any question to you? Doipude, sir. Am I audible, na?
Yes, you are audible.
Okay. Okay. I think there is no question, sir.
Okay.
Who is Vikas, sir? Divakar, sir.
Yes, sir.
Yes,
sir.
please vote of formal vote of thanks.
Good evening, one and all. I am Vikas Divekar here for vote of thanks. Dr. Dnyaneshwar Pawar sir from his busy schedule come and deliver very wonderful lecture on the topic of significance of pedogeomorphological assessment in the sustainable land resources management and agriculture development. Geoinformatic approach. Sir discuss need of pedogeomorphic research and scope for geomorphic research. Also discuss the soil loss and runoff, which will helpful for our further progress. So thank you, sir. Then I would like thanks to Principal Datar Ma'am, SP College, Pune, Head of Department Dr. Sunil Gaikwad sir, then Coordinator of the coursework Dr. Devne sir, and Joint Coordinator of the coursework Dr. Dhawale sir. And also thanks all the participants for patiently listening. Thank you all. Thank you, sir.
Thank you very much, sir. And I wish you all the best for your PhD work. I know it is very difficult after the lunch session because when we participate in depression and orientation, that time same things happen with us, and maybe some students are facing this problem also. But all the way, you
No,
listen
sir.
carefully my
Our
lecture. And
participants are energetic, sir. So that's why.
thank you. Yes, yes. Thank you. Thank
Yes,
you
sir.
very
Thank
much.
you. Thank you,
Thank you,
sir.
sir.
Thank
Thank
you.
you. Wish you all the best.